Hello all, welcome to part 44 of TestNG training series. In this session, I am going to explain and practically demonstrate how to perform parallel execution of the automation tests in TestNG using attributes like parallel and thread count. So let's get started. So how to perform the parallel execution of the test in TestNG using parallel and thread count attributes in TestNG. First of all, before directly jumping on to parallel execution, we have to understand what is sequential execution. Okay. Thereafter, I'll explain what is parallel execution and its advantages. Okay. First, let's go with the sequential execution. In sequential execution, the test will be executed one after the other. Tests get executed. Okay, the automation test or the TestNG test gets executed one after the other in sequential execution. Okay, after one test is completed, then only the next test will start the execution. After that test got executed, then another test will get executed. So this is the process in sequential execution. I'll do a practical demonstration so that it will be more easy for you to understand. So guys, what I'm going to do is I'll directly jump onto the Eclipse IDE. Here we have a sample project which is already configured with all the stuff required. As you can see that in the previous sessions. Okay, under SRC test Java, there is a package known as test package. Here I'll create a class like I'll just create some three classes. Okay, first one I'll say is as register. Click on finish. Let's wait for the register to create. Okay, in this register, I'll create some test methods. Public void register with only mandatory fields. This is one of the test. Okay, register with only mandatory fields. And I'll provide @test annotation and import this @test annotation from TestNG library. That's it. Here, instead of writing the real Selenium automation code, I'll be writing a print statement. Okay, so I'll not be writing Selenium automation code. If I write so, the session will take longer. Okay, our focus is not on Selenium here. Our focus is on the parallel execution and sequential execution TestNG. Okay, so here I'll write some print statements instead. Stum.out.println, and here I'll say the class name, that is register, then the method name register with only mandatory fields. Then here I'll append with something, guys. At the end, I'll append with something, that is plus thread dot current thread dot get ID. Okay, you see, threads will be allocated, guys. Okay, if you go for multitasking in Java or something, what happens is multiple threads will be allocated so that multiple tasks can be performed at the same time. But here, I am first demonstrating only the sequential execution where only one thread will be allocated. Okay, just to prove that only one thread is getting allocated for all these test methods one by one. The test methods will be executed only on a single thread. To demonstrate that, I'm printing the thread ID that is being utilized by all these test methods for execution one after the other in sequential execution. Okay, that's why I provided thread dot current thread dot get ID. I'll create one more method. Few more methods I'll create in this register class. Similarly, I'll create login and create few more methods, and then search class, and then few more methods, test methods. Okay. Register with all fields. By providing all fields, you are going to register here at the rate test. I'll do one more thing, guys. I'll give the priority there itself so that we know which one executes first inside this particular class. Priority is equal to 2. The same thing, guys, just copy paste this one here just to save time. Priority. Okay, then register with all fields and thread count, thread dot current thread dot get ID. The next one, I can copy paste if I require. I'll just modify the names and all those stuff. Priority is equal to 3. Register without providing any fields, without providing any fields. If you try to register, it should give warning messages, right? Generally. Yeah. Now for last test, not take much time, guys. I'm just copy pasting so that will save our time. Register with register a duplicate account. Try to register a duplicate account by providing a duplicate email address. Okay, which will not be possible. Anyhow, you'll get a error message in real time. So we have to verify whether it's not allowing you to register. Okay. Done, guys. 4 tests I created in the register.java file under the test package. I'll create one more class now. I'll just, did I provide the priorities? Yes. Okay, I'll create one more class now. Right click new class. I'll name this class as login. Click on finish. Now here, under the login, I'll create test methods. Public void login with valid credentials. Login with valid credentials. I'll say add the rate test over the mouse and import this and give priority is equal to 1. Say system.out.println. I provide the name of the class, name of the method, and I'll append that with plus thread dot current thread dot get ID. Done. Next one. For next one, I'll copy paste this method just to save time. I'll just modify the details. Login with valid email and invalid password. Okay, this is another test. I'll copy this, paste it here. That's it. Copy this, create one more test. 3. Login with invalid email and valid password. Then fourth test I'm creating. Login with invalid credentials, that is invalid email and invalid password. Both are invalid. Then fifth test I'm creating. Login without credentials, without providing credentials. That's nothing but. This test is also completed. For total 5 tests along with the priorities I have given in the login. Similarly, I'll create one more class known as search. Click on finish. I'll create a method public void search a valid product. At the rate test over the mouse, import this, search for a valid product. Here I'll say system.out.println. I'll give the class name first, followed by the test method name. Then I'll append that with thread dot current thread dot get ID. Okay. Now I'll copy this method. I'll give the priority first of all. Priority is equal to 1. Copy this. I'll create around 3 test methods here. Second test method I'm creating now. Search an invalid product. Search an invalid product. Then third one, search no product. Don't give any details. search without providing any product details. Okay. So 3 tests I created in the search.java, and 1 to 3 are the priorities. That's okay. Now 3 tests are there. Now close all this stuff, and I'll create a TestNG XML file containing all these classes containing all the test methods, so that I can run all these 3 classes containing all the test methods at a go. Where register is containing 4 tests, login is containing 5 tests, and search is containing 3 tests. 5 plus 4 plus 3, that is around 12 tests are there, guys. 12 test methods are there. So how these 12 test methods will be executed? Okay, they will be executed sequentially, one by one after the other one. Okay, they will be executed, and in a sequential order they will be executed. Right click new, right click TestNG, convert to TestNG, I have to say, and you will be creating the TestNG XML file directly under the project with all these 3 tests. You see, login, search, and register. Click on finish. Here I'll change the order of the execution. The TestNG XML file. First, I would like to run the register tests. There, I would like to run the order I am changing. You see, first register related test will run, then login related test will run, then search related test will run. That's okay, but here I'll do some changes, guys. I'll tell you what are the changes. I created 3 classes: register, few methods, login, few methods, search, few methods. Print statements I created, and then now created the TestNG XML files. I'll create test tags for each class above, like register test, login test, search test, like this. Instead of putting all these classes in a single test, what I'm going to do is, I'll copy this. I'll remove the comments, guys. I'll remove the comments. Unnecessary things I'll remove. I'll remove this thread count also for a while. Okay. When parallel execution, I'll include it again. So I'll copy this test tag, paste it 2 times. 2 times. Okay. First one I'll say register test. I'll name this test as register. Under the suite, we have the register test, and here only register class will be there. This is a better way of organizing for now. And here, this is going to be the login test, and here only login class will be there. And here I'll make this as a search test, and here only search class will be there, package.search. Okay. Now, this is one thing. Is there anything left out? I removed the thread count. Now I have to run the TestNG XML file. You will see that test will run in a sequential fashion on a single thread only. There will be a single thread allocated. Okay. How many test methods are there overall? In this, 5 tests are there. 5 test methods are there. In this, 4 test methods are there. In this, 3 test methods are there. But here only one thread will be there. One thread will be like, for example, guys, you went into a hotel. You went into a hotel. There is a hotel like this. Okay. There are 12 people. 12 people means 12 test methods across 3 classes, right? First register class, then we have login class, and we have search class. All of them 12 are there. Okay. But there is a hotel. Assume that there are hotel. 12 people went to the hotel, but in this hotel, surprisingly, only one table with one chair is available. Only one chair. Okay. Only one person can sit and eat. What we will do? Out of 12 people, only one person will go and occupy this table. After this person completes the eating, then out of the remaining 11, another person will go and occupy the table. Then another person, then another person. Like that, sequentially, one after the another. First person, second person, third person, fourth person, fifth person, and finally, 12th person will be going and occupying the table and eating. Okay. This is what is a sequential order. What is the problem with this sequential execution? Time will be wasted, right? As you can clearly see, only one table, one chair, and here 12 people came, means 12 people have to wait for every person to complete their meal. Okay. First person completes the meal. If he takes some 30 minutes, after 30 minutes, another person will go and occupy, and then he may take 25 or 25 minutes, let's say. Third person, after waiting for 30 and 25, that is 55 minutes, that person will go and do it for 40 minutes. Okay. Like different people will eat at different times, right? So amount of time, right? So every person has to wait until the other person comes. This is what is sequential execution, guys. Here time will be wasted, as other people have to wait. Same thing here, guys. This hotel having this hotel is something where there is a single table and single chair. This single table and chair is nothing but a thread. Only one thread got allocated here. Okay, in sequential execution, only one thread will be allocated, and all these 12 test methods will be running one by one on the single thread. Okay, if this thread is occupied with one test, other tests have to wait for this thread to be free. Then only the second test can run on this thread. Okay, that's what is the concept, guys, at a high level. Okay, fine. And also, what is the order of the execution? As you can see, the order of the execution is pretty clear here. First, the order will be given, priority will be given to the TestNG XML file. In this TestNG XML file, first register test will run. The test of register will run. Okay, thread will be occupied with all the register tests because we have given this register as the first priority here in the TestNG XML file. And under this register also we have given the individual priorities, priority 1, priority 2. Out of all these 4 test methods, okay, thread will be occupied by this register with only mandatory fields first, then register with all fields next, then register after it is completed, then register without providing any fields, then register a duplicate account, fourth position, that is. After all the register test methods are completed, then next test related test methods will be running where login related. So then login will start, and here also priorities are there. Login with valid credentials will run first, and after the login with valid credentials is completed, then login with valid email and invalid password login. Then after that, login with invalid email and valid password. Okay, only one thread is there, so they have to wait. These test methods will wait for their priority to come. After all these 5 are completed, then finally, as per the TestNG XML file, search test will run, where search has 3 things, and in that also priorities are there. Search a valid product will run first, then search an invalid product, then search for no product. This is the order that they will be executed. Okay, we'll see that, but only one thread will be allocated on only one thread. That is, if you take the real world hotel example, only one table, one chair is there. Only that one person has to sit on that table or chair. Okay, table with chair to eat, and the next person will go and eat. Like the same thing will happen here, guys. That table and chair is nothing but a thread here, and here number of people are nothing but the test methods that need to be run. Okay, 12 test methods are there across all these classes, and the order in which they will be executed, I already told you as per the TestNG XML file, the order mentioned, and also in the individual classes, priority attribute is there. As per that order, the test will be executed. But this is a sequential execution, guys. Okay, so one by one, right click run as TestNG suite. It will be a bit fast because these are only print statements. You will see that first register related tests are running, register with only mandatory fields. What is the thread? Allocated thread is thread ID is 1. After this particular test method got executed on the thread 1, on the same thread, the next test method will be executed from the register class. Then next test method will be executed from register class on the same thread. Next test method from the register class as per the priority. Then after all the register tests are completed, this part is completed. Then second test, that is a login. Again on the same thread, 5 login tests will be executed one by one, sequential order. Okay. Then search, all the search tests in sequential order will be executed on the single thread. You see, thread IDs are same. That means on a single table, everyone is eating one after the other. Okay. So this is what is sequential execution, guys. After register test, then login test, then search test. Okay. So here we have search test, right? Search test. Okay, fine. Here it is. Let me run it again. Right click run as TestNG suite. Yeah, now it came properly. Register test, login test, and search test. Okay. Total 12 tests. This is what is the sequential, guys. Only one thread will be allocated, and a single thread, all the tests will be executed one after the other in a sequential and according to their priorities and the order in which they are mentioned in the TestNG XML file. Now, let's go with the parallel execution. So, what is parallel execution and how it is different from the sequential execution? In sequential execution, okay, so all the tests were running in a sequential manner, one after the another one on a single thread, right? But in parallel execution, the test will get executed simultaneously at the same time. Multiple tests will be executed simultaneously at the same time. While one test is running, other tests will not wait for this test to complete. Okay, other tests will not wait for this particular test to complete. So if you talk about, let's say, One example for sequential execution is, let's say there is a railway station. Okay, there is only one counter. In the railway station, there is only one counter where the person who is giving the tickets is sitting in the counter, and a lot of people came. Okay, so the train will arrive in just next 15 minutes, and there are like 20 people, 20 or more than 20 people standing in a line before that counter, and that person who is issuing the tickets is taking a lot of time. Let's say for every person he is giving some ticket in a slow manner. Okay, so here the people who are standing in a line has to wait. Okay, they are very concerned that the train is going to come in 15 minutes, and this ticket count person who is issuing the tickets has to complete giving the tickets to all these people, 20 and above people in that time. Okay, so it may happen, it may not happen. It may happen where the person who is issuing the tickets may not be able to issue the tickets to all these people in the specified time. He's wasting the time, right? So for every person, if he's taking 2 to 3 minutes, assume that there are 20 people, it will take 60 minutes, that is 1 hour, but train is approaching in 1 hour. Okay, 15 minutes. So that's what is the problem with the sequential execution. The other person who is standing next to the line has to wait for his or her turn to come to take the ticket from that issuer. Okay, and that's because only single counter is there on, all these people are standing in a line, and that person cannot give tickets at a time to everyone. Okay, so one by one that person will be giving. That is sequential execution. But if you go with parallel execution, let's take the same railway station example where there are multiple counters. Okay, let's say there are 10 counters and 20 people came. Assume that there are 20 counters. Okay, 20 is too much anyhow. Let's say 10 counters, otherwise 10 counters, and 10 counters are there. Even 10 is also big number. Even 5 counters are there, and this 20 people came. Okay, so what this 20 people will do is they will divide by themselves into all these 5 counters, right? 5 people in one counter and 5 people in another counter, 5 people in another counter and 5 people in another, and like that 5 5 5 5 they will be dividing. That means tickets are being issued for multiple people at the same time, 5 people at the same time. At a time, the capacity is 5 people at the same time. If it is taking 2 minutes, 5 to the 10 minutes, for example, okay, or 3 minutes also, let's say every person it is taking 3 minutes also, the ticket counter people will be giving up to 5 people in 15 minutes. The train will approach in 15 minutes. You see, the problem is resolved. The time has been saved and everyone gets the ticket and they can get into the train. This is what is parallel execution with a real world example. Here, the tests need to run. The tests not all the tests don't have to wait for another test to be completed. Rather, okay, rather multiple tests will run based on the slots available. Okay, based on the threads available. We are going to decide the count of the threads. In sequential execution, I have shown earlier only one thread was allocated with an ID 1, and all the test methods were running one after the other one on the single thread known as 1. If you can see the results. But here in parallel execution, this is going to change. We'll be allocating multiple threads. Okay, some IDs will be allocated that multiple threads. It may be 2 threads or 3 threads or whatever the threads, and multiple tests will be running simultaneously because there are multiple places. If you take the hotel example, earlier there was only one table and chair where only one person can sit and eat, and other if 12 people go to the hotel, 9 to 11 people have to wait for their turn. Okay, but here 12 people go and there are 3 tables with 3 chairs. That means 3 people can go and sit at a time. Remaining 9 people will wait. Okay, and if any of the slot gets cleared up, immediately if out of these 9 people, remaining 3 people will go and sit and eat. Okay, then 6 people will be remaining. After they completed, like at least the time will be saved, right? If you increase the slots, let's say if you increase the slots by for 12 people are there, there are 6 tables, let's say. So it is more easy now. First 6 people will go and eat, and then next 6 people will go and eat once their slots are completed. Okay, once the tables are cleared up, we'll go and sit and eat. Okay, so test gets executed simultaneously, and so this is what is the advantage, guys. Test gets executed simultaneously. So you already have known the purpose here. With these examples, real world examples I gave, you already got the purpose of the parallel execution. That is saves time, saves execution time, because the test node don't have to wait for other tests to be completed. Okay, so because multiple slots are there, multiple threads are there, multiple tests can run simultaneously, and that automatically saves the time. Okay, okay, fine. So here system performance may lag. There is one drawback. Even though there is a advantage, but there is a drawback, guys. System performance. If I am running this multiple tests, okay, if these are real Selenium automation tests, you see, uh, if so many browsers open up in my single machine, which doesn't have enough system configuration to handle such kind of browsers, number of browsers at a time execution, automatically the performance of the machine will go down. Okay, the machine may not respond properly based on the CPU and RAM size and all. Okay, the system may not respond properly and will run the test very slow. Ultimately, even though you are running the test parallel, okay, even though you are running the test parallel, because of the performance issues of your machine, if, because of you don't have required required system configuration like better CPU and better RAM, then this approach is not going to work out, because ultimately when multiple tests will get executed in different browsers at a time in Selenium automation or whatever the automation, the test will run very slow compared to the individual execution time. Individually, if you run the test will run very fast. But if you run multiple tests at the same time in a single machine, what happens? The performance of the machine will become low, and the test will run very slow. Okay, so that's what is one drawback, guys. Okay, that all depends on the type of the machines you are using. If you are using a very good machine having very good configuration, that doesn't, this drawback won't be there. Okay, and also there is a solution for this drawback also. To when you enable the parallel execution, there is a solution. Okay, there is solution. Instead of single machine, we can use multiple machines. Okay, we can connect multiple machines over the network, and then we can run tests on those different machines. Okay, so that is possible, guys. Okay, so there are solutions. Okay, we are not saying that parallel execution is not possible. Parallel execution is possible, uh, is fruitful, and it saves time when the configuration, system configuration support, or there are multiple machines to run your parallel executed tests. Okay, one test will run on one machine and another test will run on another machine. It will take some, it will be faster, right? We have to find out the ways to run the test faster. Okay, so I'll explain more about the distribution of the test later. Okay, but for now let's focus on the purpose of the parallel execution is to save time. Okay, and that is possible only with a better system configuration and better way of infrastructure you have. Okay, the network or computers, or a single computer which is very good in speed, anything is fine. Either a single computer which is a super fast computer is also fine, or you don't have super fast computers, you have normal computers which can run one test in a smoother way, then you have to connect multiple machines. Okay, that kind of approaches we follow, and parallel execution will be fruitful, and it is going to save the time. That happens in real time, guys. Okay, we will be fruitfully making the parallel execution possible. Okay, so because multiple tests will be executed simultaneously at the same times on either different machines or on single machine, if the single machine is a super kind of having good configurations and has a capability to run the parallel test at the same time without degrading the performance of the tests. Then for enabling the parallel execution, we have two attributes, guys. That is parallel attribute and thread count attribute. Okay, we have to mention something like, for example, I'm saying, okay, for example, parallel is equal test. We have to mention at the suit tag level, and thread count. How many slots? How many threads you want to allow? The sequential execution only one thread was there, but in parallel execution you want multiple threads. Okay, you want multiple threads. So here I mentioned two threads means in a hotel. Imagine that in the sequential execution earlier in the hotel there was only one table and chair out of 12 test methods. Okay, 12 people going to the hotel, one person can only sit in it. Then remaining 11 people have to wait. In that 11 people again, after the table gets vacated, then next person will go like that. But here I am saying two threads. Two thread count is equal to means two tables and two chairs are there where two people out of 12 people, two people at a time can go and eat at same time, so that somewhat time is saved, and remaining 10 people will wait for their turn. And once any of the slot is completed, other person will jump in, or the remaining people will keep on moving and until all the people complete their meal. Okay, So we are increasing the thread count. The thread count can be 2, thread count can be 3, and so on. Okay. It depends on us how many thread counts we want to give. According to the machine configurations and system configuration supported, without degrading the performance, we have to decide the thread count. We have to control the number of tests which need to be executed parallelly. That's what I am saying. Okay. So these two attributes, parallel and thread count, we have to mention at the source tag level for now. I'll explain more about this parallel and thread count, how the test will be allocated to this test methods will be running on this allocated threads and all in detailed manner in diagrammatical manner in the upcoming sessions. But for now, in the coming sessions, I'll do that. But for now, let's get a feel of how the parallel execution will work. Okay, let's get a feel of how the parallel execution will work, where tests will be executed parallelly. Okay, so how the threads are allocated to this test methods and all those stuff. Let's see that. Okay, earlier there was only one thread, but now we have like 2 or 3 threads. Let's see. Run the test in parallel mode. How to run the test in parallel mode? Here 2 tests will execute parallel at a time. I'll explain how these tests getting allocated to the allocated threads in detail in the next session. I told you, right? So let's do that parallel execution. First of all, I'll close this, and here at the suit level, I'll add something like parallel attribute. This is one of the attribute. Parallel is equal to, I'll say true, guys, and comma space, sorry, space. Parallel is equal to true is one thing, and thread hyphen count is equal to, I'll say 2. Okay. Here parallel is equal to test, guys, not true. Test. Parallel is equal to test is one thing, and thread count is equal to is another thing. You have to give it correctly. Parallel and thread count are 2 attributes. At suit tag level you have to give. Don't give for now at the test tag level. I'll explain more about when to give at suit tag level, when to give at the test tag level later. But for now we are giving these 2 attributes at the suit tag level so that it will be applied for all the tests. Parallel is equal to test and thread count is equal to 2. More detailed explanation of parallel is equal to test will be explained in the next session. So we'll wait for that. Okay. So guys, this is the thing. 2 threads will be allocated. How the test methods will be executed parallelly, we'll see that. Okay, how many 2 threads will be created? That means 2 slots are there for execution, and there are multiple tests to be executed. And how these tests are occupying these 2 tables in the hotel, like that, we'll see that. Okay. Now run these tests are going to be executed in parallel. Parallel execution. Here only 2 slots to be 2 tests to be executed parallel. Okay, we can increase the count if required. Right click, run as TestNG suit. 2 thread IDs will come. You see here 2 thread IDs are there. At a time 2 tests are running. For that you see uh, thread IDs thread IDs 21 and 22 are allocated. 2 threads are there now, 21, 22. You see everywhere 20, 21, 22, 22, 21, 22, 21, 22, 21, 21, 21. Okay. So what's happening here is this test method has occupied this thread known as occupied this table or thread known as 22, while parallelly another test from register has occupied this next one. Okay, there is 21. Okay, here here you see from login test it has occupied this 22, and from the second register test it has occupied 21. Then from login with valid email and invalid password occupied 22. Then other thread ID register with all fields or running on 21, and so on. Register login, and finally search term came where 21, 21, 21. Okay, so it got executed like this, guys. Okay, there were two threads. If the execution is very fast, if it is taking time, for example, if this has taken time, the remaining slot they are taking. Okay, the test methods are taking. Here, ultimately, what's happening is there are 2 threads and 2 tests are getting executed parallelly. Okay, let's run it again. Let's see if there is any difference in the execution. Yeah, you see it all depends. Okay, 22, 21, 22, 21, 21, 22. 21, 22, based on the available slots, guys, based on that situations and all. You see, finally all are running on 22 actually. Okay, so they are so fast that okay, once it is cleared up, another it may take 21 or 22. These tests are very faster. That's why they are like this. If you attach some time thread dot sleep or something, you will see the difference, like they will be allocating one thread and all those stuff. Okay, so anyhow, this is what is the parallel execution, and it's going to save the time. Okay, it's going to save the time, guys. Okay, So completely it took 149 seconds. 149 seconds. Okay. Parallel execution it took 149 seconds. What if I remove these things and if I allow the sequential execution, how many seconds it is taking? Let's see. Right click run as TestNG suit. Sequential order, only one thread will be allocated. And here it's taking less, guys. You see, 86 seconds it is taking here. Okay. And if I enable this, parallel is equal to test and performance of the machine matters maybe. Okay. Thread hyphen count is equal to 2 if I say, then how many seconds again I'll check. 115 more seconds it is taking. So we'll do one thing, guys. We'll do an experiment where I'll add thread.sleep here. Okay, intentionally I'll add thread.sleep so that the test will not be so faster. Okay, thread.sleep as some 2 seconds I'm giving. Yeah, 3 seconds. Something I'm giving 2 seconds. Something I'm giving 3 seconds. Something I'll be giving here 4 seconds. This one. Here I'll be giving again 2 seconds. If this test is taking time, then advantage of parallel execution will come into picture. That's the reason I'm doing that. This is a register. Then I'll go with the login. 2 seconds. Sorry, 3 seconds. Then 4 seconds. Let's give it as 1 second. Here 2 seconds again. Here search 1 second. Here 2 seconds. Here 3 seconds. Okay. Let's see what will happen in this case. I'll do sequential execution first. I'll go to TestNG XML. I'll remove this parallel and thread count. This time the tests are going to take time because we are intentionally provided thread.sleep. So sequential execution is going to take time. Okay, let's see that. First test occupied with the thread 1. Only one thread is being allocated because another, okay, sequential execution, right? Only one thread is allocated here. One by one they are running. How much time they will take? Let's see. Only one thread will be allocated, one with the ID 1. Yeah, 12 tests, and it took us 29 seconds, 29, around 29.167 seconds it took, guys. Now I'll enable the parallel execution. Parallel is equal to test and thread count. I'll give something like this. Thread hyphen count is equal to 5. I'll give. Let's see what will happen. Five threads are there. Okay, 5 threads will be allocated. Okay. Right click run as TestNG suit. Let's see what will happen. 5 tests at a time will be running, guys. Okay. You see 21, 22, 23. Even though I'm giving 5 threads, but these threads are, some threads are like idle. Okay. So it was faster, as you can see. Earlier, how much time it took? Now it took just 29.205. Earlier, I don't remember how much time it took, but it was faster this time. Okay. It was faster this time. Fine. Anyhow, if I give 12 here, let's see what will happen. You will see the difference, I guess. Okay. If I give 12, you will feel the difference. All the 12 will be running, but here all the slots are not getting allocated, guys. Okay. 21, 22, 23 are only coming. Okay. Somehow it's like this. Okay. Parallel is equal to test from, it's not about test methods, guys. Here here test methods are not running, here tests are running. Only 3 will run at a time. I'll explain you about this concept, guys. Even though thread count is 12, but one group will only occupy one thread. Okay, here giving 3 is equal to 12 only. Okay, there is no other no difference here. Okay, because it's parallel is equal test. I didn't explain you. I'll cover you. Okay, so otherwise I'll do one more thing. So just to make the difference, what I'll do is I'll just change it to parallel is equal to methods here. Parallel is equal to methods. Thread count is equal to, what is the thread count here? Register has 4, right? 4 I'll say. Or I'll say parallel is equal to methods at still 5 slots I'll give. Let's see what will happen. Is any difference is there? Let's see. Run as TestNG suit. One test after the another test will run anyhow. Four things are happening. Maybe the time has to be reduced. Okay. Again, it's giving some random time only. Okay, that's fine, guys. Okay. So parallel execution, if you go with real-time example, it will be more easy. Okay, here Selenium automation code or nothing is there, so we are not able to figure it out. But in reality, parallel execution will save time. Okay, because multiple things will be executed at same time, multiple tests will be executed at same time. Because of that, the time of the execution will be reduced. Okay. I'll remove this thread dot sleeps. So here better to provide parallel is equal test and thread count is equal to whatever 2 or something. Okay, 2 or 5 is enough. Okay, so this is a better way. So multiple threads will be allocated. Maximum 5 threads will be allocated based on the availability of the threads. And it was very fast this time. Okay, so it took 142 seconds, guys. Now it's working fine. In 142 milliseconds, the test got executed. And without this, how much time it is taking? Let's see. Sequential execution is take a lot of time, I guess. Why the tests are very fast? Okay, I removed the thread dot sleep, right? That's why they are very fast. Okay. So fine. Anyhow, this is sequential execution where tests will be executed one by one, and in parallel execution, tests will be executed parallelly. Okay. At least that one you remember, and definitely it's going to save the time, guys. Okay. And there is one more thing, guys, that is Selenium grid. Okay. Maybe the performance of the machine is getting impacted. Okay. That's what I told you, right? Even though it is going to save time because by running the multiple tests parallelly, but ultimately your machine has to support that performance. Okay. If the machine is not supporting that performance, ultimately, even though you enable the parallel execution, the test will get delayed. Okay. That's why you are seeing some difference, right? When I'm running sequential execution is taking more less time than the parallel execution because the performance is getting impacted in this machine. Okay, when it is trying to run multiple machines. So what we generally do is, if you go with Selenium automation, guys, we have a concept known as Selenium grid, which actually distribute the test across multiple machines, and so that multiple machines have their own configurations and tests will be distributed across multiple machines, and TestNG will make it parallel so that in very less time the test will be executed. Okay, it is a combination of Selenium. For example, in Selenium automation, it is a combination of Selenium grid plus TestNG combination will use for better performance and execution and to save the time. This actually will save the time, guys. Okay, sometimes in a single machine, if you see, you will not see any difference between parallel execution and sequential execution, but you incorporate Selenium grid, what happens is, if there, for example, there are 5 tests, let's assume that there are 5 tests. Each and every test will take 2 minutes. Let's say each and every test will take 2 minutes. 5 tests, five total. How many minutes sequential execution? 10 minutes. In a single machine, if you are running one test after the another one, means total 10 minutes it will take. But with Selenium grid, what you will do is, let's say you're connecting this machine to 5 other machines. Okay, 1, 2, 3, 4, 5 machines you are connecting. So machine 1, machine 2, machine 3, machine 4, machine 5, and this is your laptop or something. Okay, from where you are running the test, and one of the tests will go and fall into this machine and run. second test will parallelly run here. Okay, they will be distributed, guys. Okay, they will be running, not running in a parallel execution. Only with Selenium grid, only distribution will happen. Parallel execution will not happen. Okay, that means after one of the tests runs in this machine, another test will run in another machine. It will be still sequential execution only. But if you attach TestNG to the Selenium grid, then what happens is Selenium grid with TestNG combination will make what means all these tests 1, 2, 3, 4, 5 will run parallelly on 5 machines at the same time. So this one will take 2 minutes, this one will take 2 minutes, 2 minutes, 2 minutes, 2 minutes, and simultaneously it's happening. So in within 2 minutes, all the tests will be executed. But real time in sequential execution, it was taking 10 minutes, 8 minutes got saved. Okay, but in real time, guys, you will have thousands of tests. Assume that how much okay, if you have 5 machines and okay, divide by 5. Okay, divide by 5, that much time will be, if each and every test is taking 1 minute, assume that, okay, in 200 minutes it will be completed. 5 to 100 is 1000, right? In 200, instead of 1000 minutes, in 200 minutes it will be completed. That is the power of the combination of Selenium grid and TestNG, where the test will be distributed to different machines. Either you should have a single powerful machine, or you should have multiple machines which can run the single test smoothly in a speed way. Okay, otherwise even though you enable the parallel execution, you will not get the proper results. Okay, proper time savings, because your system will ultimately running multiple tests will make the system slow. Okay, it will make the system slow. Fine, anyhow, that's what is about the parallel execution of test in test and using parallel and thread count attributes, guys. So I practically demonstrated. So I'll explain more about this one, how the threads are allocating and all those stuff in detail in the next sessions, like parallel is equal test, how it is allocating the test methods to the tests to the threads. All these things I'll explain. A lot of topics are there, guys, here. Okay, all these are parallel execution topics only. So I'll go on. They're very simple topics, guys. We just started with a detailed session on the parallel execution, but this will not take that much time. Okay, they are very simple topics. They will be one by one. I'll be covering. Okay, they are very simple topics. If you want this, the remaining topics are dependent on this topic, guys. So be aware that you complete this topic before approaching the next topics of the parallel execution in TestNG. Okay. So guys, that's all for this session. In the next session, I'm going to cover another TestNG topic for you. Till then, see you. Bye bye.